Now, over at the Apache NuttX project, we have a problem with GitHub runners. Sometimes during peak periods, we use too many of them. I am not sure why, and this is a very bad thing. Now, I am not sure if I'll be around when this problem happens again. That's why in this video, I am documenting everything that I know about this problem. Hopefully, someday, this video will help our NuttX team to troubleshoot this problem. Now, in this video, we'll talk about this mysterious number here, full-time GitHub runners, why it matters so much to NuttX project, and how it's computed. But first, important thing to note for everybody in NuttX project, we must always keep this number below 25. See this full-time GitHub runners. Right now it's 4. That's happening for the past 24 hours. We have to keep this below 25. Where does this come from? Okay, in a while I'll explain, but for now let me just copy this over. So this metric here, it's updated live. It has a few numbers that we need to be concerned about. Okay, let's look at this. I'm going to copy down the numbers here. So last updated, here. Oops, moving on. Last updated, as we saw earlier on, is actually at, 11 p.m. UTC. Next thing we have is that the dates, okay, we can ignore that for now. Elapsed hours is 24. So we actually keep updating the stats every day, every few minutes. And this stats has been running for 24 hours. Next, we have the GitHub job hours, which is 15.8. GitHub job hours, 15.8. We have a GitHub runner hours. And that is 117. Okay, I'm just going to copy these numbers down because I'm going to explain one by one how we got this. And last number is full-time GitHub runners and 4. GitHub full-time runners. Well, let's push it up a bit. GitHub full-time runners 4. Yeah, I'm just going to copy these numbers down because after a while it will change, it disappear, it will reset to 0. So that's why I'm taking these numbers down so that I can explain what's going on. Okay, and this is the number that we should always keep below 25. Right. What is the significance of this number here, 25? Why 25? Why does it matter? Now, if we look back into the official documentation, we are looking at GitHub action policy. This is coming from the ASF infrastructure team. So look here, this line here. Average number of minutes a project uses per calendar week must not exceed the equivalent of 25 full-time runners. Right, so it gets a bit confusing. Okay, firstly, let's clarify a bit. What exactly is a full-time runner? Well, think of full-time runner as a metric for measuring how much of GitHub actions we're actually using. So think of a GitHub runner as a process at GitHub that will execute all our CI jobs. The higher the number, it means that we are actually running more CI jobs at GitHub, right? If we exceed 25, it's a bad thing. It will get a bit confusing. We talk about 25 GitHub runners, but with the unit that we use here, it's actually across a week, a calendar week, 1 week, 7 days. Yet at this figure here, we're looking at GitHub runners across 24 hours. Well, the good news is that when we calculate a full-time GitHub runner, it averages out. So when we talk about GitHub runners full-time, whether it's per day, per week, per month, it's the same. It will actually average out to the same number. So when we say keep this below 25, it means every day we should keep this below 25. Every week we should keep this below 25. Every month we should keep this below 25. Yeah, it sounds a bit confusing, but that's the way it works. Full-time GitHub runners is the averaged out number. Think of it as the number of runners you need, to execute this all the CI jobs in NuttX, assuming that the GitHub runner is running 24/7. So it's running, continuously 24 hours. It's running continuously for 7 days. It's running continuously for 1 whole month. When you average out, it actually works up to be, the same metric, right? This is a bit confusing. Some folks may wonder, why is this metric valid, even though it's for 24 hours? Well, we are using full-time GitHub runners, and once you average out as full-time GitHub runners, it doesn't matter whether it's by day, by week, or by month. Okay. So we have the okay. So this is something that we must comply. Now, what happens if we exceed 25 full-time runners per week? Well, here's what it says here. Projects whose build consistently cross the maximum use limits will lose their access to GitHub Actions until they fix their build configurations. Okay, this is a terrible, terrible thing. It means that, consistently cross the maximum use limit. Consistently cross? Yes, there will be spikes. Maybe within 1 day, we might exceed 25 full-time runners, but maybe on weekdays we'll get higher load, and on weekends we are lower load. If we average out and it works out to be below 25, that's fine. So 25 across a week is okay. So this metric here we see here, not strictly accurate. It might spike out on weekdays, it might go down on weekends, but it's a good guide. We need to average out the whole week, make sure it's below 25. Then there's a definition about consistently cross the maximum use limits. How consistently? So we're thinking 1 week or 2 weeks. If we exceed 25 full-time GitHub runners for 1 week, 2 weeks, 3 weeks, 4 weeks, that's very, very bad news. That means that ESF infrastructure team will cut off our access to GitHub Actions. Right? So this is a very fine line we're working at. Yes, it's really good to put in lots of CI checks, lots of CI checks and CI tests and all that in GitHub. Yes, because it improves the quality of our code. We want to make sure that every single PR gets merged into NuttX. It's perfectly okay. It's have been built okay. It tests okay with QM, EMU, and all that. Yes, the more tests we put in, the higher the quality of our code. But if we put in too many checks, if we build too many things, if we run QEMU tests too often, we might exceed the 25 full-time runners, right? And what happens? ASF infrastructure team will cut off our access to GitHub Actions, which means no more CI checks, no more builds, no more QEMU tests. Well, isn't that worse? So, it's zero quality now. There's no way for us to check whether things are actually correct before we merge a PR. So it's a very fine line. Yes, it's good to have lots of CI checks. On the other hand, too many CI checks will mean that we will exceed our 25 full-time runners, and we will lose access to GitHub Actions. And when we lose access to GitHub Actions, we will no longer be able to verify the code that is being checked into NuttX. So it's we're walking a very delicate balance between the two, hard rock and a bad place. We will have to make sure that we don't go either direction. Right. Moving on. Let's talk about these numbers. What do they mean? Right. We have a metric here. We saw earlier on. Okay, it's going to reset very soon. So I'm just going to use this thing here. This is a metric that we computed ourselves, running on our own server. In fact, this script is running on the NuttX dashboard server. If you saw my earlier video, this metric refreshes every few minutes, which means if you put this up onto your web browser, login GitHub.io, blah blah blah, GitHub full-time runners, this metric should auto refresh, okay, or refresh itself, and the numbers will be updated. We compute these numbers every few minutes. We have the last updated. It tells you when these numbers were computed. In this case, it's quite close to midnight UTC. Okay, why do we use this number UTC? Why do we refresh it every midnight? It's for convenience. Midnight UTC happens to be the time where NuttX activity is mostly quite low. As we cross the midnight UTC, these numbers will reset to 0. So it's a good place to start. And as the day drags on, we will see the numbers increasing. The load increases, right? And at the end of the day, again, midnight UTC, it resets, right? So this is actually a good time to reset the numbers. It's quite close to what we expect from the daily loads that we see in NuttX. The next number that we have here, elapsed hours. It's close to midnight UTC. So the stats that we see here are actually for the past 24 hours. Okay. Now, next we have the GitHub job hours, 15.8. How did we get this? Is that we look at the build jobs that are running. We have a script that will scan through all the build logs in GitHub for NuttX, and we will add them up. This is for NuttX repo as well as the NuttX apps repo. We look at the duration, we add them up, and we get 15.8 hours. In a while, I'll show you how this relates to the number in GitHub. Right. GitHub runner hours. There is some magic going on here. 50.8 is a definite number. It's something that we can see ourselves from the GitHub build logs. However, to convert this number into a full-time GitHub runner, there's a bit of magic. We found out that the magic factor is actually 7.5, right? So if we take 15.8 times 7.5, our magic number, you get this figure, right? How did we get 7.5? Well, we actually kind of reverse engineered. Frankly, we have stats from the ASF infrastructure team. Yes, it tells us that past 30 days we have usage of this minutes and this number of full-time runners. Okay, but we had to use our own stats, our own metric, because this thing not very helpful. It doesn't update throughout the day, and also only selected people within the NuttX team are able to access this report. Not very useful, whereas our own report is updating every few minutes and it's accessible by anybody in the world. Then we're not quite sure how they computed full-time runners and minutes and all that. That's why we kind of reverse engineered. We look at these numbers here. We compared to the hours that we counted in GitHub, and we worked out that the factor is about 7.5. That's why we take 15.8, we multiply by 7.5, and we get GitHub runner hours. This number will mean that for the past 24 hours, we are using roughly 117 hours of GitHub runners, right? Yeah, the metric gets a bit fuzzy, but well, we are looking at the full-time GitHub runner metric, so that's the metric we need to go by, and therefore we have this number. Now, this is the good GitHub runner hours for the past 24 hours. What we do is that we take this number, 117, and we divide it by 24, because we have 24 hours from here, right? And when we divide the number, we will get this, full-time GitHub runners. Remember I said that the GitHub full-time runners doesn't really matter whether it's for day, for week, or by month. It's because of this division here. We divide the number of GitHub runner hours across the elapsed time period, divide by 24. Therefore, this number that we have here, 4, it's applicable whether it's per day or per week or per month. No matter what happens, we must keep this below 25. So 25 is like the averaged out number across that time period, right? So don't be confused when we say that GitHub full-time runners is 4. Yeah, it's applicable for day, for week, or for month, because the number has been averaged out. Right. Yeah. So far we talked about the number, GitHub full-time runners, how we computed this runner by looking at the GitHub job hours. I will show you in a while how we got 15.8. Yeah, and the magic number 7.5. We couldn't quite figure out how to convert these numbers, so we actually did some reverse engineering. We looked at the number from the actual ASF infrastructure reports. We take this number, we divide it by the number of GitHub hours, and we have this magic number 7.5. Right? Okay. Now, next thing we'll talk about is okay, 25. Have you ever wondered why 25? Why do we need to keep this below 25? Now, it's not really clear here, but let me explain. There is a secret reason why 25, and I'll explain it to you now. Okay. we are, of course, the Apache NuttX project. We are all wondering, why are we only allowed 25 GitHub runners? Right? The reason is this. That okay, first let me backtrack a bit. How did I find out how this all works? Well, I asked this question to the ASF infrastructure team over Slack. There was time 1 year ago that we were seriously exceeding the 25 runners. So I asked them, could we increase this number, 25 runners, ourselves? Could we pay for more runners, right? Or and maybe to help us manage our costs, could we impose a hard limit of 25 runners? I think the infrastructure team folks, just laugh at me, and told me, no, that's not possible. Why is this happening? Well, that's because everything is coming out of a common pool of GitHub runners. And this pool of GitHub runners is shared across all Apache projects. So we have our friends at, let's say, Apache Minute, right? How many GitHub runners do they get? Well, they get 25 runners. That's because if you look at the policy here, well, this policy applies to everybody across all Apache projects, NuttX, Minute, everything, right? So if you think about it, okay, wow, this is going to be huge because we have NuttX taking 25 runners, Minute taking 25 runners. There could be other projects, so Apache XXX. How many runners do they get? 25. Apache YYY, they will also get 25 runners. Now everything comes out of this common pool of runners, and that explains why we can't do much about it. Can we exceed? Can we pay for more than 25 runners? Can we exceed 25 runners? We can't. Everything is coming from a common pool of GitHub runners. It's kind of restricted. It's a limited resource. We should not exhaust it, right? Can we do a hard kind of limit, to make sure that we never exceed 25 GitHub runners? We can't. It's coming from a common pool. We cannot do a hard limit of 25 GitHub runners. If we exceed 25 runners once in a while, it will come from a common pool, right? Now, here comes the main reason why we need to restrict 25 runners. What happens if NuttX takes up more than 25 runners for a extended period of time? Say one day, we decide, let's go ahead and use up 50 runners because there's nothing to stop us from doing that, right? Everything is just coming from a common pool. Well, imagine what happens to these guys. Minute, Apache NuttX, Apache YYY. Well, we will affect them. Because we are taking more runners, we will actually end up having less runners for the other pools. So yes, we can happily take up more runners, but we are hurting the other projects. It means that some poor developer in Apache Minute project will wait forever for the GitHub Actions job to start because we are out of GitHub runners. There's no way that the Apache NuttX Minute project can start unless there are sufficient GitHub runners available, right? So it's a very bad thing. That's why we should never exceed 25. Because if we exceed 25, we are hurting other projects, right? And that's the reason why we're using a common pool of GitHub runners. Unfortunately, it's a limited resource. We cannot expand it. Even if we have the cash for it, we cannot grow it. We're all sharing the same resources. So it's a very delicate ecosystem. we have to be very friendly, very nice to other projects, in this ecosystem. Anything that we do badly will hurt others, right? So yeah, it's a very tricky thing. Yeah. So if you look back at this whole GitHub Actions policy, it sounds very fierce and all that, but there's a reason for that, and that's what I found out after talking to the infrastructure guys. So therefore, never exceed 25 GitHub runners because somebody else will suffer. Right. Moving back to our numbers here. Okay, let's switch back. We talked about the GitHub job hours. How the heck did we get this number? Well, let's look at a sample build in NuttX to see what's happening. We go to the NuttX repo. Let's go into actions. And we go into build. Now, so we see interesting numbers here. Now, we have jobs that will run quicker. This is 1 hour, 17 minutes, 1 hour plus. We will see jobs that will run a lot slower. 1.5 hours, 2 hours. The maximum we'll see is 3 hour plus. Right? Why is this happening? Now let's look at something complicated like this. Right. What does this all mean? Yes, it took 3 hours plus to execute all this, right? And how do we know the actual GitHub job hours? Is that if we scroll down, we can see usage. We click on that. So the elapsed time is 3 hours. But as we know, we actually run a lot of jobs in parallel. We have ARM, we have RISC-V, and so on. When you add up, when you stack them up, the actual usage of GitHub runners is a lot more than that. That's why we have this usage stats here. We click on that. If we scroll down, we'll see this number here, which is actually quite shocking. 1 day, 5 hours, which means that we actually consume 24 hours plus 5 hours. That's 29 hours of GitHub job hours. 25 hours are spent on GitHub doing this build. This is a lot, right? That's why it adds up quite quickly. Maybe to explain what's going on, well, I'm going to walk through with you what happens when we do a build. Let's go back to this. This again. What does this all mean? Why is it doing a fetch source, select builds, and we have 20 jobs and all that? Right. Back to our drawing. This explanation is going to be quite important because we made some changes 1 year ago because we ran into issues with our GitHub usage. Now, we have a developer who submits a PR. Right? Now, what happens to that PR when it's submitted to NuttX is that it goes into our CI system. Right? Now, when we create a PR, we have scripts that will identify the kind of PR. Whether, for example, we will see arc is ARM. Which means that architecture for this PR is ARM. It could be ARM, it could be ARM 64, it could be RISC-V, and so on, right? So this corresponds to the architecture folder inside our NuttX directory. When we see ARM, it means that we have updated some files in the ARC folder, right? And this we see in the PR as a label. Besides ARC, we also have board. Remember in NuttX we have a board folder, Same thing. We also label it as board ARM or ARM64 or RISC-V and so on. Right? Then we have things like you know OS components. We have something like drivers, right? And so on. Why do we do this labeling? This will be important in a while. Okay, let me just shift it a bit. Now, what happens next is that we have a step here that's called fetch source. Now, we know that the NuttX repo doesn't build in isolation. It needs to be combined with the NuttX apps repo because all the app code is there. To boot NuttX successfully, you need the app also. So fetch source will consolidate all the code. It will get the code from NuttX apps repo. It will combine with the code in the PR. It will merge everything into one huge bundle, and it will use that for the build. Right. The next step that we see in the log is select build. So this goes into select build. Now this was added 1 year ago to address our problem of our huge usage of GitHub runners. Why is this happening? Select builds will look at the labels. If we see that architecture is ARM, well, we don't have to build the entire NuttX code base. We will just build only the ARM code, right? Actually ARM32. Because if we change anything in the ARM32 architecture folder, there's no way that it can affect ARM64 or RISC-V. Therefore, why build everything in NuttX? In the past, we used to build everything for every single PR, and that was hitting our quotas quite quickly. Nowadays, we are a bit more intelligent. We will look at the labels. Like if we see architecture ARM, it means that we only need to build the ARM targets. If you look at the ARM targets, we will see things like ARM 01, 02, and up to 14 or something, right? So which means that when select build sees that architecture is ARM, we will build only the ARM targets. Same thing for board. If we see that the board is ARM, we will build only the ARM targets, right? But if you see things like architecture is ARM and ARM64, or board is ARM and ARM64, we will have to build both ARM and ARMs. We actually had to build, sorry, not both, but we built everything. That's why we have the concept of whether a PR is a simple PR or a complex PR. We only have two types. Simple PR means that architecture ARM, only one platform, therefore we build only ARM code, the ARM targets, ARM1 to ARM14. However, if we see multiple architectures, let's say it's something that affects ARM and ARM64, then it goes into a complex PR, which means that we will call everything. Things like OS components, driver, it's also considered a complex PR. We will build everything, right? Not just ARM64, but also RISC-V. Yeah, so be careful when we submit PRs. It's better definitely to submit a simple PR. If we look back at this, at our build logs, we can see that right, this is a complex PR because it has to do with drivers. That's why it builds everything, ARM, RISC-V, and so on. But there are simpler PRs. For example, this PR here is only ARM64, and it builds only ARM64, and it completes fast, 1 hour. If we look back at the PR, we can see the labels. See, the label says ARC ARM64, board ARM64. Therefore, the labeling process helpfully tells us that this thing is only for ARM64. Therefore, please build only ARM64 targets, right? And it's quite fast. But the worst case is that it will be a complex PR, and that's where we have to force ourselves to build everything, and it'll take 3 hours plus. Right. We talk about labeling a PR and how we select the builds and all that. Then after that, we execute the builds. Now, what happens during the build? We have a few things happening in there. Firstly, is that yes, we build NuttX for all these targets, right? Okay. But the second thing that we do is that we actually run also CI tests. So we're not just building NuttX for all these targets, but we also have inside them some CI tests. It's not very obvious, but we look through a lot. When you look through the GitHub build log, we will see the CI test. What is a CI test? CI test means that we are booting up QEMU, okay, inside NuttX. Inside GitHub. We're booting QEMU inside GitHub. We are booting NuttX in QEMU, and we are running a series of tests, to make sure that all the features are okay, right? So this boils down to the quality assurance of NuttX. Firstly, important to build NuttX. We want to make sure that any PR that goes in, yes, it must be built correctly. If it fails the build, too bad. You have to fix it, right? We want to make sure that every single PR that's checked into NuttX will actually build successfully. And the second thing about quality is about the CI test. Yes, we know that it builds correctly, but functionally, does it work correctly? That's why we have the QEMU and the CI test. It will execute a whole barrage of tests, there'll be a whole test suite to make sure that every single feature in NuttX still works correctly, that NuttX still boots correctly on QEMU, the console I/O is still working and all that. So it's actually quite a complex series of tests that's happening. Yeah. So if you multiply that by all the targets, we have ARM64, RISC-V, we have other exotic targets like AVR. Yes, we have extensor, right? It actually works up to quite a lot of jobs happening. We have so this means that we actually consuming quite a lot of resources in our CI system. That's why our builds are so complex, and that's why our builds take so much time. Elapsed time is 3 hours plus, 3.5 hours, and the usage, the number of GitHub hours that we actually consume is 1 day 5 hours. Right. Right. By the way, this number here is reflected here. When we see GitHub job hours, we are actually calling the API to list through all the jobs that have completed and how much time they take. So we're actually adding up these hours here. Right. So if you wonder where this number comes from, GitHub job hours, it's actually here. Right. Okay. Now, okay, the screen seems to have frozen. Let me just restart a bit. Okay, good. AVR sensor is up. Now, our build is super complex, as you can see, right? This will take 3.5 hours elapsed time. It will take over a day of GitHub runners to complete. The question now is this sustainable? Are we sure that if we keep doing this, we won't eventually run out of GitHub hours? Remember, we are supposed to meet the 25 full-time GitHub runners. And how do we compute the 25 full-time GitHub runners? Well, we saw earlier on, right? If we have the GitHub job hours. We saw earlier on that it could be as high as 1 day for a single job, right? And then we multiply that by 7.5 to get the GitHub runner hours, right? And we divide it by the elapsed time, 24 hours, to give the GitHub full-time runners. This number must always stay below 25. So now it becomes a problem. If this thing gets too complex, there is a chance that we will exceed 25 full-time runners, right? So what can we do about it? So this part gets really tricky. NuttX build, we could do better. We see a lot of configurations that might be subsumed. So we see like smaller dev config files and larger dev config files for the very same board in NuttX. But the smaller dev config file is actually already included in a larger dev config files. So could we run a script to identify the smaller dev config files that are really subsumed in the bigger dev config files, so that we can skip the smaller dev configs. One example, smaller dev config file, a very common one is the NSH dev config. It does nothing except compile NSH shell, it boots up the NSH. Okay, but it doesn't do anything, right? There will be a more complex dev config that will do more. For example, it may bring up a graphical UI, it may do more things like networking and all that. Well, that already includes NSH. So why do we need to compile NSH again and again and again? We don't. So one of the things that we are trying to explore is that maybe we could scan through all the dev configs, find out the smaller dev config files that are subsumed inside bigger dev config files, and just simply skip through this. Ignore the small dev config files altogether because they are already covered by the big ones, right? Okay, CI test. This is something a bit concerning, right? So yes, we are going to add more build NuttX targets. Okay, it will get slower. We are also going to pile on more CI tests, which also gets slower. Eventually, we are going to hit the 25 full-time run limit. Okay, but there's a problem with the CI tests. Let me explain what's going on. The CI test, how it works is that we are running QEMU. Right? Okay, how does QEMU work in GitHub? Well, we are running it inside a GitHub VM, virtual machine, right? And how does a GitHub virtual machine work in GitHub? Well, it runs on a GitHub hypervisor. The hypervisor is the thing that manages virtual machines on the machine, on a server. And what does a GitHub hypervisor run on? It runs on GitHub bare metal. We are now looking at the very low level of the hardware. All right, this is the actual server, the machine that is running all this. Okay, when we look at this, it kind of distresses me a lot. In my previous life, I was an enterprise architect, and I get very upset when I see this. Why are we going through so many layers? GitHub hypervisor. Okay, our screen is frozen. Let me just restart it. Why are we going through so many layers? We have QEMU running on a GitHub VM, running on top of a GitHub hypervisor, running on top of GitHub bare metal. This is the actual hardware. Isn't there a better way to do this? Well, the better way to do this is we just run QEMU on top of bare metal. Now, isn't this the right way to do it? Why do we need so many other layers, and why do we make things so inefficient for ourselves? So, you know, yeah. So this is very distressing for me. Um, just because something works in GitHub doesn't mean that we should do it that way, right? So over the years, we kind of done this a lot, and GitHub is not exactly the most effective way to run QEMU, right? It's not very efficient. Running a VM, running hypervisor before it hits bare metal. The ideal way is to run QEMU on bare metal. In fact, we're doing this today. We have an experimental NuttX build farm. If you refer to my earlier video, I talked about the NuttX build farm. It's running on bare metal server, Intel Xeon server, and it's running QEMU on bare metal, and everything works fine. So why don't we do it this way instead? Yes, GitHub has convenience because we can integrate this into a job. If this fails, we will tell this it fails, and the PR will also fail, right? We run it outside of GitHub. It's going to be a bit more problematic. Yes, we need to figure out how the heck do we trigger a remote build, and how the heck do we indicate the status back to the PR if the build fails, right? Right. Okay. But yeah. So as an enterprise architect, I find this very distressing. This is not the right way to do it. So every day I'll see this, I'll just scream, no! Why the heck are we doing this with so many layers? This is not the right way to use GitHub, right? Just because it works on GitHub doesn't mean that we should do it. Okay. Now, so someone will say, okay, Mr. Smarty Pants, you have the perfect way of doing the CI system for NuttX. Well, why do I go ahead and implement this? Well, I have a problem. I suffer from hypertension. Even though I was an enterprise architect, seeing this, all this just makes my blood boil. It makes my blood pressure shoot up, and I'm going to faint if I were to do this whole undertaking myself, right? This is just way too complex. The other thing about revamping this whole CI infrastructure is that somebody needs to stand by 24/7 after it's implemented to make sure that everything is working, make sure that every single job runs fine. If something breaks during the 24/7 monitoring, we have to decide, are we going to find a fix for it, patch it up and make it work, or are we going to roll back this whole system and go back to the previous system? This is terribly stressful for me. I can't handle this, right? So, if I look at this one more day, I'm going to get too stressed out. It's not going to work for me. Okay. So my approach to this, luckily we have something called non-attachment. Something I learned from Buddhist philosophy. The idea is that yes, this is all very complex, but could we just hands off a bit? Don't let it bother me too much every day, even though I see every day and I'm gonna scream, no, why are we doing this? Well, so let me just stand back a bit, accept it for what it is. Don't let that disturb me too much. Otherwise, I will just go really bonkers thinking about this whole architecture and how to revamp it. Right? Yeah, that's what I'm doing for now. I'm practicing non-attachment, like Buddha says. But you might think, how does that compare with total detachment? So I've been thinking about non-attachment versus detachment. Well, detachment means that I'm not going to do this. I'm just going to drop everything in NuttX. I don't care about NuttX anymore. Don't bother me. I'm just going to live by myself without NuttX. No, that's not what I'm doing. I'm still care very much about NuttX. It's just that I'm trying to be non-attached for my own health's sake. The reason why I still care about NuttX, okay, so again, Buddhist philosophy has a very nice term called compassion. So we have a issue here. with compassion. Now, who submits the PRs? We have our developer here, right? Who submits the PRs very helpfully into NuttX. But we have a problem today. Our NuttX developer will have to submit a PR, wait 3 hours for the build to complete. It fails because there's a bug. So there is a fix. We wait after 3 hours. We need to resubmit the PR. Wait another 3 hours. What happens? It fails. So we have to resubmit. So this goes on and on again. Okay. Oh, so I feel the pain of this developer here. Why are we doing this? Every 3 hours, waiting for a build, something breaks, it goes again. This is very cruel to do to a real human being. We shouldn't be doing that. Okay, this is bad. So we have to do something about this. The other thing about compassion is that yes, we have builds, we have CI tests and all that. But what if we, let's say to save the 25 full-time runners, we take out all the CI tests. Well, we have another problem. Suppose we have another NuttX developer who depends on NuttX every day. When he checks out the code from NuttX, he finds that it will not boot, it fails. Probably because we forgot about some CI tests, we missed out, right? So some PR got merged, it didn't get tested correctly, the bad code went in. So this is bad, and it hurts our developer here. So I feel compassion for our friend here too. Why are we subjecting him to all this kind of torture, on code that isn't working? No, we have. I feel the pain of our developers who are working on PR, submitting them, and waiting and doing this again and again. I also feel sorry for developers who might have to check out a version of the NuttX source code and it doesn't boot because it doesn't complete. It doesn't actually fulfill our quality and requirements through our building and through our CI tests. And then there's another type of compassion that I'm concerned about. 25 GitHub runners. What happens if we exceed that? Well, we will risk the chance of hurting somebody else in some other Apache project. Apache Minute, Apache something else, right? So it's okay. So it's a difficult thing. We have to stay below 25 because if we don't stay below 25, with this strange complex architecture, we will end up hurting somebody else in some other project. Some other poor developer in some other project will have to wait forever for a GitHub runner to run. Right? Yeah. So yeah, we have a problem. So yes, I'm trying to say non-attached, but yet I feel compassion for our developers and for other projects. Yeah. So it's a tricky problem to have. I wish there was some way to solve this, but let's talk about it. So interesting note. I'm not sure if anybody has seen this thing called the Apache Way. If you haven't seen it, please read it. So the Apache Way says that, says something to the effect of, all of us are participating in in Apache projects on a totally voluntary basis. We are under no obligation to do any single thing for any Apache project, which also means that if we are ever stuck on something because it's too difficult, too hard, or it's too stressful, we can always drop it and walk away, right? And we are ready when we are ready to come back to fix this, to continue to work. Just come back and do it. So good. That's exactly what I'm doing here. Non-attachment, right? Don't get too concerned about these things. It's not healthy to think about this everything. It's not too healthy to scream at myself every day, wondering why are we running so many things on GitHub when it's not supposed to be there. Yeah. So unfortunately, the Apache Way doesn't talk about compassion. And that's why we unfortunately make very terrible decisions like this that will end up hurting our developers, in other projects. I wish that we had some kind of compassion inside the Apache way, so that we design things the right way and we don't make, fall into horrible traps of this. Okay, enough about Buddhist philosophy and non-attachment and compassion. We have to move on. Next thing we'll talk about is that we discussed these stats earlier on, right? Someone might challenge me. How did we get these numbers? Are we computing it correctly? Is 7.5 really the right number to use? So I'm just going to walk through with you the script that computes all these numbers here. And also, this might be helpful to other people in other Apache projects, because I'm quite sure that other Apache projects are also having this problem with the ASF infrastructure reports. It's just one big blob. It's not very helpful. It doesn't update itself. It's not accessible by everybody. So why don't we have a more helpful metric that's available all the time, right? Right. How does it work? Well, this is the published version of the stats. If you keep refreshing this, kind of auto refreshes. It will change, right? This is coming from this GitHub repo, NuttX metrics here, right? This PNG is auto updated by a script that will refresh it, and this PNG gets published into our GitHub.io site through Google Docs. It's automatic kind of publish. How did we get these numbers? Okay, let's look through the documentation. I've written a couple of articles to explain what's happening here. If we look at this article here, okay, optimizing the continuous integration for Apache NuttX RTOS. Inside there is a section called Live Metric for Full-Time Runners. Yes, it talks about the metric here, and we talk about the things that we spoke earlier on, how we compute the date, elapsed hours, GitHub job hours, and so on, right? So we talk about the magic number 7.5. It's actually 7.5, not 8. And we average this from past data, and so on. Right? We have a short description of the scripts, but kind of outdated. The latest scripts are explained in a separate article that I just wrote. This article is called Grafana Dashboard on Google Cloud VM for Apache NuttX RTOS. What this means is that this article explains how I installed the NuttX dashboard on a Google Cloud virtual machine. Inside that same virtual machine on Google Cloud for our NuttX dashboard, I am running the script that will compute our live metric over here. Appendix live metric for GitHub runners. The metric looks like this. And here are the steps. We set the token and we run this script called run2 inside the NuttX metrics repo. All right, what is this run2.sh that's running on our NuttX dashboard server? Run2.sh comes from our NuttX metrics repo, and this is what it does. It will just loop forever, updating the metrics every 900 seconds. What does it do when it updates the metrics? Now, it will call another script called NuttX release / compute GitHub runners 2. Okay, we'll talk about that in a while. This is a script that will go into GitHub, call the GitHub API, fetch all the numbers. Remember we talked about this? Well, it gets this number here by calling the GitHub API, and then it will sum up everything and return the result. The rest of the code here is really doing formatting. It will get the date, hours, total job hours, full-time runners, and so on. We'll do some coloring. Yes, so this this thing will actually change color. Blue means blue or purple means okay. If you see it turning orange or brown, it's bad, right? So the redder it becomes, the closer we are to hitting 25. So watch out for a number. The color. Once we do the coloring, we use a image magic to convert it into a PNG graphic. So we have a template in MBG, right? And what do we do? What do we do with the PNG file? Well, we take a PNG file and we commit everything into GitHub, which means that this thing here gets updated all the time. If we look at the history, we can see that yes, it's actually updating, every 5 minutes. Yeah, this is a very silly way to make use of a GitHub repo, but it's a database for free and it's accessible by everybody. And the good thing about this is that we also capture the logs. So if you look at the GitHub runners log, well, we have the raw numbers here. And this also gets committed every 5 minutes. So good, we have historical information now. We know exactly what happens every 5 minutes, what are the metrics, how many how many hours, how many full-time runners. So we can backtrack and figure out, over the past year, what has happened. Right. Okay, this video is getting a bit long. In the next video, I'll explain how we check out all this past historical data and how we use it to plot a graph to figure out what is the history of our GitHub runners over the past year. Right, moving back, we talk about this script here, run2.sh. It calls another script, NuttX release compute GitHub runners, to get the actual information from GitHub to fetch the job hours. And we see it here, NuttX release compute GitHub runners 2. Okay, not really interesting stuff, but we are actually setting the GitHub token. Actually, any token will do. Doesn't have to have any special access. We use the GitHub command line, to list out all the jobs for this particular date. Remember, our stats will recycle every 24 hours. So we are only fetching the jobs for that particular day. For every single job that we see, we are calling the GitHub API to get the timing. Specifically, we're getting the run duration. This number here. Okay, actually these numbers here. Because these are individual jobs, right? So we are 64, RISC-1, and so on. This job takes 1 hour, this job takes 24 minutes, and so on. What our script does is that it will iterate through all the jobs and it will fetch the timing for each job. Then we sum them up. Here, we accumulate them. Do we add them here? Yeah, so somewhere in here, we actually add up the duration. So we accumulate the duration for the entire job based on the duration for individual jobs. The magic number is, it's actually 7.4, not 7.5. So the magic number 7.4 will be used to convert the job hours. We take the job hours in GitHub, multiply it by magic number 7.4, and this will give us the runner numbers. And we divide the runner hours by number of hours elapsed so far, and we get the full-time runners, right? Okay, this script is really simple, so we can easily adapt this to any project. Okay, yeah. So I think this video has gone on a bit too long. I will just finish up. We will talk about more things in the next video. If you can't wait for the next video, you can refer to this issue that we found. Under GitHub issues and NuttX, we have this thing called warning, high utilization of GitHub runners. So we can see that this is mystery here. Over the January, February period this year, we hit very high usage of GitHub runners. Remember we said that we are supposed to touch only 25 GitHub runners? Well, when we use the ASF report, we're seeing that 12 hours we're hitting 70 full-time GitHub runners. So this is very, very, very distressing. Again, remember that whether it's 12 hours, 24 hours, 1 week, 30 days, we should always compare against the benchmark of 25 full-time runners. So 70 is, whoa, way too much, right? Yeah, but is this only happening for one single day? Well, no, it persists. So we have a lot of discussion going on, what's going on. But ultimately, we didn't really have an understanding. We didn't have data. We didn't have enough data. We couldn't figure out what exactly is causing all this runners limit. When we add up the GitHub runners over the past 7 days, we get 24 runners. This is quite close to a limit of 25. So it's really scary. If you don't do it right, okay, my mistake. This is after the end. After the peak period, we actually hit 24, which is okay. But before that, we hit a lot more than that. Okay, if we go through the whole history, there's a lot of history here. We can see higher loads. Yeah. Okay, look through it. So there's a lot happening here, but it took a while for us to load to bring down. Eventually, we ended February with a lot fewer runners, 24 GitHub runners. So which is quite okay because our limit is 25. But before that, we were hitting really high numbers. And I'll talk about this in the next video. We generated a chart. Remember we saw this, our log in NuttX metrics? Well, I dumped out the logs and put it into a spreadsheet. And we can see a pattern here. January, February 2026 really has a lot of usage of GitHub runners. We're not sure why. It's way exceeded our limit of 25. It's something that we're not sure why. It might happen again. And we have to get ready when it happens again. Right? So in the next article, I will explain how I generated this chart, how I dumped out all the runners log using a script, and explain all these patterns in the GitHub runners. What is normal, what is not. And we'll talk about some possible solutions for fixing this spike, because this might happen again. All right, we don't want it to happen because it will hurt a lot of people if it happens. So we have some suggestions for fixing this. We'll talk about that in the next video. Okay. When the next video is up, I'll put it in the description below. Any articles that I mentioned in this video, I'll also put it back. I'll also document them in the video description. Yep. So thank you so much for bearing with me. See you in the next video.